In this section, we're going to start taking a look at a number of different types of control structures, such as decision statements, and then we're going to start taking a look at the idea of arrays and multidimensional arrays. So one of the first things we have to understand is what a control statement is. And a control statement is basically a decision statement, which is basically following the form if then. And the if then statement follows the format that if there's a certain condition that's fulfilled, then there's something that's going to execute. And then else if means if another condition is fulfilled, then another one of the statements will be fulfilled and it's going to go through and execute. And then else if another condition, and you can see the pattern. So if something, then something else, then something else. And then finally, there's this final statement where if all of those fail, in other words, if this condition fails, if this condition fails, if this condition fails, and then there's a last resort, then this is what's going to execute. Now, a lot of times when we start trying to build these sorts of relational operators or these sorts of decision statements, we have some sort of relationship. And so these are the relational operators that are involved. And so we have an equal, and be careful, it's a double equal. So for instance, we have x double equal 4. So just be careful when you're building your if statements. Just because single equal means assignment as opposed to double equal means that we're looking at Boolean or we're looking at comparison. Not equal is the tilde and then an equal sign. Okay, so we just have to be careful of that. And then there's an and statement, and can be a single and or a double and. Or is two vertical lines. So if we want one condition or another condition, then we can just use the double lines there. Less than, greater than, less than or equal, greater than or equal to. These are pretty symbolic of what's characteristic of those types. So what we're going to do is we're just going to go through and we're going to just take a look at a number of different types of very basic sorts of codes to be able to execute these if statements. Right? And the first one that we have, we're going to prompt the user for a number. And we're going to do a very simplistic sort of execution where we're going to determine if the number is positive, negative, or 0. All right, so what we're going to do is we're going to start out with our CLC and our clear all. And we're going to get the number, let's just call it x. And we're going to say x input, let's say enter a number. All right, and it doesn't matter what they enter. And here's where we're going to build our if statement. We're going to say if x is less than 0. All right, so in other words, if it's going to be negative, then we're going to print f, the number, and we could just say %f, so we can reference that actual number is negative. And we're going to do \n, so we go to the next line, and let's just call that number x. All right. Now, let's say an else if. So else if x is greater than 0. We're going to print f, and we're going to say the number is positive. And we'll say %f is positive. \n. All right, and we'll comment x just so we call that number. And then finally, let's just do an else. And we can print f. Let's say the number is 0. And we'll \n. And we'll say the number %f, just because that's the format that we've done. And close that out. And we're going to call the variable x. All right. And we're going to end this. All right, so this is the syntax that we should use. All right, and I'm also going to put a semicolon there, even though a lot of times it's not necessary. there might be a Boolean value that accompanies that. So I'm just going to run that as is. And let's just go ahead and execute. All right, and let's just test it all 3 times. So let's say, for instance, x is 0. Well, the number 0 is 0. No surprise there. Let's run it again. Let's say -5, and the number -5 is negative. And I spelled negative wrong. And finally, let's just say x is 55555, and that's a positive number. So this is essentially how our if-then statement is going to work. So pretty easy, right? Not too big of a deal. Right? Now, a second example. We're going to write Matlab code to prompt the users for a coefficients of a quadratic equation in the form ax squared plus bx plus c, and we're going to compute the discriminant. And the program will then determine if there are 2 real roots, 1 real root, or 2 complex roots. All right, so I'm going to go ahead, I'm going to get rid of this, and let's call it a. So remember that the quadratic formula, so we're going to say %a, so quadratic ax squared plus bx plus c is equal to 0. And remember our quadratic formula. So x is equal to the opposite of b plus or minus square root of b squared minus 4ac. And then we would divide all of that by 2a. And you might remember that the discriminant is actually this part. Okay, so that would probably be helpful to know what the discriminant is. All right, so this is all we're going to do is we're just going to produce b squared minus 4ac. So let's let a be equal to input, and let's just call this enter a or quadratic of the form ax squared plus bx plus c equals 0. Right? And we're just going to do that a few times. So let's call this b, and let's call this c, and we'll just change these to b and c. All right, and I'll put some semicolons after here so that way there's no echo printing. All right, now let's call disk for the discriminant. Discriminant is equal to b squared minus 4 times a times c. And there's one of 3 cases. All right, so if disk is less than 0, what that means is that there are 2 complex roots. So we're going to print f. There are 2 complex roots. And \n. And let's do an else if. So else if, let's say disk is greater than 0, then let's print that there are 2 real roots. And then finally, now notice the double equal. Okay, so we're going to say else if, and we don't really have to do this. We could just do else, but I'm just going to do it anyway. Else if disk equals 0, then we're going to say that there are, or there is 1 real root. All right. And we're going to execute this just to make sure it's good. We're going to hit an end here. I'll put a semicolon. All right, so I'm going to enter 1 and 2 and 10. And I know that ax, or if we have x squared plus 2x plus 10 equals 0, that should have 2 complex roots. Right? And there are 2 complex roots. Right? I know that the quadratic x squared plus 2x plus 1 has 1 real root, which it does. And then finally, if we had, let's say, 2x squared plus 3x plus 2, all right, two complex roots. Let's find something that has two real roots. So let's say 2x squared plus 3x plus 1, there are two real roots. All right, so pretty cool that this program can actually figure out the number of real roots for some sort of quadratic. Right? Now, one last problem. So we're going to take a look at this animal. And we want to use the function rand. Right? And rand produces a number accurate to 4 decimal places between 0 and 1. And we're going to generate a random number between 0 and 100 using the function and assign it to a variable x. Then we're going to use an if and we're going to print out these four statements. Right? So we're going to print low if the number is in the domain from 0 to 25, 25 to 50, somewhat likely. So maybe it's like a probability type problem, whatever it might be. All right, so let's get rid of this stuff. Okay. And we're just going to go ahead and we're going to say x equal rand. But we want the number. Now, I'm going to go ahead and execute this just to show you what happens. So if we run this, then this is the number for rand. All right, 0.0975. And if I run it again, 2985, and notice what happens. It just produces a random number. But we want a number between 0 and 100. So let's just multiply it by 100. And those are going to give us. And check down here. Just keep that in your view. So each time I execute it, we just get a new random number. All right. So now x is a random number between 1 and 100, accurate to 4 decimal places. So now let's go ahead and we can go ahead and execute. So we're going to say if, let's say x, and I'm going to use parentheses. Let's say x is less than or equal, or let's say greater than or equal to 0, or x is less than 25. Right? So here's our or statement. Okay, actually it should be and. I'm going to use a double and there. All right, and again, we're looking at this statement right here. We're going to print low if the number is between 0 and 25, exclusive 25. All right, so we should probably just use less than. Then we're going to f print f. We're going to say low. And we'll backslash n, and that's that. Now I'm just going to go ahead and copy this. And I'll just else if. Probably should have waited, but that's fine. So else if, and then finally we just say else right here. All right. So now let's fix the conditions. All right. So if x is greater than or equal to 25 and x is less than or equal to 50, we're going to say somewhat. All right. And if x is greater than or equal to 50 and x is less than or equal to 75, then we're going to print out the word likely. And then finally, if none of those conditions fit, then we're just going to fit, or we're going to print out high. Right? And we're going to end this. All right. So let's go ahead and execute this and just see what happens. All right. So we get the word high, and we print it again, and there's high again, and there's likely. All right. So it's kind of scary for a moment because it was only giving high. So let's just print a few times: high, likely, somewhat, likely, low, likely. Let's print out f, or x, excuse me. So let's just see what happens. Let's f print f. Say the value of x is, let's say %f, and let's just do 2 backslash n's, and let's call x. Right? So let's run it, and the value of x is 3, and clearly that's a low value, all right, because it fits this domain. All right, we'll run it again, and the value is 27. So that's actually really cool that we got a number that was somewhere in between there. And we'll run it again. We got 4, that's low. We got 9, 82, which is high. It fits into the else category. I'm just going to keep running until we get likely, and the value of x is 69. Okay, so this is actually a really cool example as to how we can go through and use some really basic if or else if statements, so that way we can all see how we're going to go through and try to utilize these if statements. Now, in the next videos, what we're going to do is we're going to take these a step further to see how we can utilize these with respect to some of the different sorts of numerical methods and some of the stuff that we're going to be doing later in the course.